Hello and welcome to the Capgeminis podcast, brought to you by Classiq, the quantum algorithm design company. My name is Yuval, and my guest today is Julian van Velzen, lead quantum technologist at Capgemini. Julian and I spoke about which technologies are overhyped and underhyped, about customers that were helped by Capgemini, his predictions for 2022, and much more. We hope you enjoyed this episode. Please let us know how we did by emailing hello@classiq.io. That's hello@classiq.io. Hello, Julian, and thanks for joining me today.
My pleasure. Great to be here.
So who are you and what do you do?
Right. So my name is Julian van Velzen. I work for Capgemini. So what do I do? So most of all, I'm just a quantum nerd, right? I'm just very intrigued with this amazing technology. But within my role, I am the CTIO for quantum technologies, and I lead the quantum division for the Capgemini group.
And this is you've got a new group now, right? Quite a few consultants, I believe.
Right. So we just have a new initiative to make sure that we will be on time and to help our clients to become more quantum ready. We had a bunch of activities already throughout the group. So we do various things on all three levels. So both on communications and networking, quantum sensors and computing. But now I have the pleasure to lead another group that will make sure that that we'll prepare ourselves and our clients for this thrilling quantum futures.
Congratulations. So, where do you think clients are with regards to quantum? Do you feel that most of the time you have to educate them on what's going on and what the risks and opportunities are? Do you think that clients are ready to experiment? Do you think they're moving into production? I mean, where do clients stand in your experience on that spectrum?
So it's absolutely early, right? So for most of the clients, it will be 5 to 10 years or even more, out there before there's any scaling or productionalizing of any solutions. Um, I think there's a big variation of where clients are. So some of them, they have a specialized team, quantum physicists. They have some publications. They build new algorithms to very low level algorithmic design. But I think the majority of them is still trying to figure out, how do we kickstart our quantum journey, and that involves a whole bunch of things. It's not just developing new algorithms; it's just as much figuring out, who are your quantum champions, who within my company is working on this, what could be possible use cases, how do I go from, some use case that you can find online to something more tangible where you actually, start building something. And the majority of them are starting to look into this. Whereas, only a few years ago, the majority of them had never heard of it. They had no team, no commitments whatsoever. So I think a lot of them are moving forward and are taking the first steps now.
When a client wants to take the first steps, do you feel that they want to build internal expertise and keep the knowledge in-house, or do they just want to completely outsource it and do a proof of concept that a company like Capgemini does? Where does it stand on that spectrum?
So I think the number one and two and three priorities maybe is to build competencies and to build knowledge, right? So yeah, I don't think it makes too much sense to outsource everything. Um, what it does make sense to outsource is to get some help because it's not easy to get started in this area, right? It's really you can really kickstart your journey if you have someone that knows how to map an algorithm to a quantum or how to map a problem to a quantum algorithm, or that has already some access to a network and to some hardware vendors. Because if you have to start on this alone, it may take years before you have an idea about how this technology is developing, and if it's so quickly developing, you always run behind.
So they go to Capgemini to help with your prior experience in working with customers to identify use cases and your experience to say, oh, you should try this environment or this vendor, and so on. Is that accurate?
Absolutely right. So in some cases it's more about figuring out what use cases are and how to prepare for them. In some cases you can already start start working on them, right? So you can already try out some algorithms, see how they work, and in some cases improve the algorithms. In some cases, of course, you can get some insights and improve your classical solutions, so all kinds of quantum-inspired solutions, and there may already be a small benefit as well.
To what extent are customers focused on the hardware vendors, on the arms race? Oh, I've got 30 qubits, I've got 50 qubits, I've got 70 qubits, but next year I'll have 107 qubits. How much are customers focused on that?
Right, so it's easy to to go with the hype and follow the new latest trends. More qubit to the mix. It's always sounds good. It's good, of course, to realize that there are so many more metrics that are important to follow. So I think many of our clients are watching this space and are exploring, who to partner with and what kind of hardware strategic partnership should be made. I think the purpose of this is to build relations and to learn and to experiment and to have access to a network. I think if you are really advanced and you already are developing algorithms, at that point it becomes really important to have some actual hardware because you can increase the quality of your algorithm in such a way that it maps specifically to a hardware, to certain hardware, right? So I think the first value is just to get access to a network and build strategic partnerships. And the second, more technical benefit is to build hardware specific algorithms.
And allow me just to explore this point on the strategic relationships. Is it more important for a company to secure a relationship with a hardware vendor, say Honeywell, or with a cloud vendor like Microsoft or Amazon that may have multiple quantum computers on their cloud? Which one are you recommending to your customers that they pursue?
So I think it's a little bit of a different purpose, right? So it's easy to experiment with AWS Bracket or Microsoft Quantum with various types of hardware and software, right? So I think quantum inspired or simulated annealing kind of algorithms are quite big, prominent on these platforms. I think if you want to experiment on a deeper level and really build hardware specific algorithms, it makes maybe more sense to partner with either IBM or Rigetti or Honeywell or any other, because of course they have this hardware available.
And I didn't mention IBM just not to confuse the question, because IBM obviously makes both hardware as well as allow cloud services. So I was purposely choosing hardware vendors only and cloud vendors only. Is there a particular customer story that you're able to share, perhaps on the quantum computing side, someone that you worked with, and what were you able to do together?
Right. So let me not name, but so we work with many clients in financial services. One of those clients, one of the typical use cases is portfolio optimization, right? I think that's where many clients are working on. They came with the idea that for them it was also really to build momentum within their own team. They just wanted to have like a lighthouse project that would help them pave the way to see what kind of talent they would need, what they would need to start doing to get more quantum ready, what business units to connect to. So this was a project I was personally involved in the past few years. A year ago for it was like a half year project, and it was really really awesome to see that if you just start doing something, if you just pick some quantum champions in your group, and find some eager people to work on this, have a clear vision of what you want to develop, and get your hands dirty with either Qiskit or whatever. You can get so much more insight on what this technology would mean, and it helps you to get this new way of thinking of how quantum technologies may disrupt a big part of the system, even though the problems that you're working on are still very small toy problem kind of situations.
So these problems are small, but the algorithms are roughly the same. And I guess customers are expecting that with better hardware, newer hardware, they will be able to run larger and larger problems until the problems become truly useful. When do you think that will happen? When would a financial services customer doing portfolio optimization be able to run a meaningful portfolio beyond what they do on classical computing side?
So this is always a very tricky question to answer, of course, right? And I think it's important to be very realistic about that the real value of quantum computing is still far out there, right? And it's a large scale, broad quantum advantage, something where quantum computer would actually do something useful. Probably is 5 to 10 years away, or even further, or it may even never happen. That being said, I think it's not a all or nothing a moment, right? So there will be small, very specific advantages of quantum algorithms. It will be quite likely that this will maybe first in chemistry or a kind of situations, and then maybe finance will be amongst the first as well. And then it will be something very specific. And then every year, I think we will see a bigger and broader advantage of these computers. And that being said, I think so. Of course, now so far we really talked about quantum computing. There's of course many opportunities as well in quantum sensors and quantum networks, which may actually be more mature than quantum computers are at this point.
So when you look at your team, I think you mentioned maybe 20, 30 people.
Yeah.
How are they roughly divided between computing, communications, and sensors
So I
or
think
security?
Yeah. So we have a big security branch as well. It's not really in my team though, so that's a different group of people. I think sensing is a little bit more of a niche subject, right? I think it has a huge potential for specific clients, in particularly in all kinds of intelligent industry applications. But it's considered for the right reasons a little bit more as a niche. Um, I think so. I think that's a bit less. I think quantum networks is definitely very interesting. So as Capgemini, we have a quite a strong brand as Capgemini Engineering. Roughly 50,000 people working on telco related use cases and all kinds of things that are very low to very close to hardware interfacing. And particularly there, we do a lot of things with quantum networks as well. And I think this is something that is a little bit overlooked with larger companies at this point. Quantum computing is very yeah. Everyone talks about quantum computing, and it's maybe even a little bit overhyped. But the other two areas are equally interesting, I would say. And then, of course, for security, this is so before you ask, when we will see added value or a advantage for quantum computers, security, which of course is completely classical, right? So migrating to safer cryptos and safer mathematics that these cryptos use. Um, that is definitely something which I would recommend all of our clients and all companies to start working on today. And so we already have a bigger team there as well.
You are in a really excellent position in the industry. I mean, you work with a lot of clients, you work with a lot of vendors, you're part of a fantastic organization. So I think you're super qualified to answer my prediction question. What do you expect to happen in 2022? I mean, if you don't know it, then no one does.
Well, and I certainly don't know it. Well, I mean, there are many roadmaps out there, of course, right? There's IBM and Google stated they have 1 million qubit machines in 2030. Some of the smaller players stated they will have even fault tolerant larger systems in 2025. Probably pretty optimistic, but we'll see. Um, I do think that we'll get a quantum advantage pretty soon, like maybe in 2 years or so. But it will be very specific, very small. So I think this will be the big next, one of the big next events to watch. Another milestone to watch is some true error corrected systems, even if it's just for a couple of qubits. Um, I think another trend, what we will see is that it's really technology focused still, right? I mean, we'll talk about qubit systems, and then error correction, and then how it's kind of like we have a hammer and we're looking for a needle still. I think this will also turn around. So it will be much more about what will be the business impact of these systems. What if you're a airplane manufacturer and you can simulate a large part of your systems in the quantum computer and reducing your time in the wind tunnel by 20%. What if you can improve the success rate of phase 3 trials by 20%? What would that change? Would that change just your algorithmic landscape and your compute landscape, but probably also all your business model, your support IT, and everything around it. So I think that the sooner we'll come to quantum technology maturing, the more relevant this will be. So if this is already in 2022, well, I hope so. I think the pace is really picking up. It's remarkable what we have seen, in the past couple of years, what has been developed, the increased awareness and of the possible applications. The hardware is developing rapidly. The software is getting better, right? So it's for certain algorithms, you need a fraction of the amount of qubits that we thought you would need a few years ago. So let's see. I'm very eager to learn what we'll get in 2022.
So if I gave you a magic wand and you could control the quantum industry for, say, the next year, what would you have us work on? We are awaiting your commands, Julian. What do you want us to work on for the next 12 months?
Right. So I think that quantum computing is very promising, but maybe a little bit overhyped. I think I think sensing and post quantum crypto is underhyped. So I think that it's not just the industry where we should work on, but all companies should get more awareness for these technologies. What I'm personally and as Capgemini as well, very interested in are the possibilities for quantum technologies for sustainable development and building new kinds of technology breakthroughs that will help in reducing our carbon footprint. I think there are some amazing opportunities, right? From industrial catalysts to computational fluid dynamics related things, or other type of product design and other types of energy production that could leverage the amazing power of quantum computing. So I really think that this could be one of the most important areas where we could work on and where we could leverage quantum computers for.
And even when you think about problems like traveling salesperson, route optimization, that doesn't impact the generation of energy, but it could potentially reduce the usage of energy.
Absolutely, yeah. These latest NLP models, right? So, for example, GPT-3, I think that uses the same energy as like a small city does, right? So, so one thing is, I guess, is to have quantum computers help in getting the technologies that we would need to get to be more sustainable. But in some way, quantum technologies can also improve operations, like traveling salesman, or even reduce the energy dependency for large models and large machine learning.
Excellent. So as we get close to the end of our conversation, what do you think is holding back the quantum revolution? What are the key concerns that you're hearing from your customers?
So I think one of the key areas is that it's a new way of thinking, right? It's just when we moved from single computing to parallel computing, we had to think about new ways to parallelize our workloads, and all kinds of big data tools came from it. And we have to adapt to this new way of exponential thinking, right? Like, what are really the problems if I have a bunch more, like much more compute power, what would I do with it? So I think a big part of it that is our imagination. Of course, that translates into a whole number of very tangible things, right? Talent definitely is a limiting factor. We need people at the interface of physics and mathematics and AI We need people that have not just this knowledge, but very clear domain knowledge as well. If we talk about finance or things like portfolio optimization, we have to figure out people that know exactly how these problems are working. What are the constraints? What are the optimization functions? What is the non-linearities? What is, how do the problems look and feel? And having all these different skills and knowledges in one person, of course, is very hard to find. So skills definitely is another thing.
How can people get in touch with you to learn more about the work that you're doing and that Capgemini is doing?
So everyone can always send me an email. So maybe just say it here. My email is julian.van.velzen@capgemini.com, or just add me at LinkedIn, and I'll be very happy to have further discussions on this topic.
Excellent. Thank you so much for joining me today.
Thank you so much for having me. It was a lot of fun.